All right, so we're gonna do aliquots. Yay! Everybody loves aliquots. No, we don't. Okay, so I am going to go through the way that I have been doing aliquots versus, and then just double checking with the book and how they do aliquots. So we're gonna do my way first because I'm in charge here. So I'm gonna do my stuff in blue, and then maybe bright green for the book, how they do it. Okay, so a prescription calls for 50 milligrams of chlorpheniramine malate. Using a prescription balance with sensitivity of 6 milligrams, explain how you would obtain the required amount of chlorpheniramine malate with an error not greater than 5%. So first we have to find the minimum weighable quantity. So let's do that over here. Min quantity weighable. So we take the 6 milligrams and we divide that by the percent error. So 6 milligrams divided by 0.05, and that will be 120 milligrams. So that is our minimum weighable quantity, is 120 milligrams. So to find the aliquot, we take our minimum weighable quantity and then take away the amount that we are going to use, which is 50 milligrams. And we find out that that is 70 milligrams. So then you want to find the minimum ratio that you can do. So this is the minimum amount that you can put together and save as much material, which in our class, it was just find any number, any ratio. This is kind of a way to do it. This is a step process. So 120 divided by 50, I have my calculator off screen. That is 2.4. Well, this isn't like a nice round number, so we're going to round it up to 3 just to make that all nice. So we're going to multiply both of these, and they're going to have the same ratio then. And so we get this to 150 milligrams, and then this will be 210 milligrams. And so we're going to have drug, and then we're going to have diluent. So our drug is 150 milligrams, and then our diluent is going to be 210 milligrams. And we want to find out the total, and I will show you why in a second, which is 360 milligrams. Okay, so then we want to find the percent strength of our aliquot. So the percent strength is your active ingredient, which is your 150 milligrams, over the total of your aliquot, which is 0.416. So this is our strength. I will hit ratio. Okay. And then, so you take the amount which you originally were going to need, and you divide it by the percent strength, and that will find out how big your aliquot is, which is 120 milligrams. Yep. So that's how much we need to weigh out. And so the way that we do this aliquot, we will almost always get this as our aliquot. which is your minimum weighable quantity. So when you do it this way, you will be saving as much of your diluent, and so this is a more practical way to do it actually in the lab. So let's look at the answer in the book, how they wanted you to do it. They had, for them, they had drug was 150. Okay, so that was the same as us. And then their diluent was 450, which is almost twice as much. So their total was 600 milligrams. And so if you find the percent strength of that aliquot is 0.25. So it's a much weaker aliquot than ours. So take the amount that you need, divide it by the strength, and then you find it's 200 milligrams that you have to weigh out to find the amount. So if you were doing it this way in the lab, you would be wasting about 80 milligrams of material. So one of the reasons why you should probably do it this way. Okay, so a prescription has a balance sensitivity requirement of 0.006 grams. Explain how you would weigh 0.012 gram of a drug with an error not greater than 5% using lactose as a diluent. So the first problem I have with this is that I would change everything to milligrams. So that becomes 6 milligrams, and this becomes 12 milligrams because we multiply it by 1,000, because for every 1 gram, there are 1,000 milligrams. And so that makes it much easier to handle. So now we need to find our minimum weighable quantity. So we're going to take the sensitivity requirement, which is 6 milligrams, and then divide it by 0.05, and that will find 120 milligrams again. So now we're going to do, we're trying to find 12 milligrams, okay? So let me actually highlight these two so that you know where these are coming from. I like colors. All right, there. So you know where everything is coming from. So then we take 120 minus 12 milligrams, and then we find 108 milligrams. Okay, so these are going to be our two starting ratio numbers for the aliquot. So let me, there's that, there's that, there's this. That's a whole new number that we have now. And then, all right, so we take 120 and divide it by 12. We find that that's 10. I don't know if this is going to confuse people way more. And so this is now our ratio. Our minimum ratio is times 10. So we can do times 10 for each one of these. So this is going to be 120 milligrams, and this is going to be 1,080 milligrams. And then so we take drug, 120 milligrams, and then diluent is 1,080 milligrams. And so that is going to be 1,200 total milligrams. So then we have to find percent, or well, not percent, just the just the strength of the aliquot. So we find that we take the drug and then we divide it by the total. Hey, it's a nice 10% strength. And so we take the desired amount. So our desired amount is 12, and then divide it by our percent strength. And so we find 120 milligrams needs to be weighed at the end. So if you can follow that. So, and then, I don't know if I'm gonna do any more highlighting. Highlight all the things. All right, so that you can kind of see, well, that should not be, let me unhighlight a few things. All right, that should be orange because that's a different number. Okay, so kind of works. If you can follow, if you can read that, but I won't be highlighting like that again. So let's see what the book does. What color was I using earlier? Oh, purple. So the book, they do drug, they also do 120, but they dilute it, diluent, they mix in 1380. So they have a lot more, almost 200 more. I mean, it's not a lot, but it's a lot. All right, so they find 1,500 total. And then finding their percent strength is 0.80. That's their strength. And then, so you take 12 and divide it by their strength, and you find that they have to weigh 150 milligrams. So there's a 30 milligram difference between the two. Okay, a torsion prescription balance has a sensitivity requirement of 4 milligrams. How do you weigh 5 milligrams of hydromorphone hydrochloride with an error not greater than 5% using lactose as diluent? So now it's not 6 milligrams, it is 4 milligrams. So we'll have to do that. So min quantity needed. So that would be 4 divided by 0.05, and then that is 80 milligrams. Okay, and then so we take 80 as our new one, and then we want to find 5 milligrams. So then we find out that we have left over, and then those will be used in our ratio. Our ratio is 80 divided by 5. That equals 16. And then when we multiply these by 16, that's a large number. Find that this is 80, and this is 1,200 milligrams. Okay, so then our drug diluent, and then our total. So we have 80, we have 1,200, and then this is 1,280. All right, and then now we want to find our strength of our aliquot. So we do 80 over 1280, and then that's 0.0625. And then, so we wanted to weigh out 5. So we find the strength, and that is 80 milligrams that we have to weigh out of our aliquot. So let's look at how the book did it, the book had drug, they also had 80 milligrams, but then they diluent 1520, so that's 1600. So then their strength is equal to 0.05, and then 5 divided by 0.05 equals 100 milligrams. So the waste on this one would be about 20 if you didn't do it my way. Do it my way. Okay. A torsion prescription balance has a sensitivity requirement of 0.004 grams. Explain how you weigh 0.008 grams of substance with an error not greater than 5%. So we have to find, well, so we're going to convert these two to milligrams. So this is 8 milligrams, and this is 4 milligrams. And the way that you get that is you multiply them by 1,000, because there are 1,000 milligrams per gram. So minimum quantity, I don't know why I'm quantity is 4 divided by 0.05. So then you would find it's 80 milligrams again. Okay, so we take 80 milligrams minus, what are we looking for? 8 milligrams. Okay. And then so we find that that's 72 milligrams. And then we need to find the ratio. So the ratio is over here. So we take 80 divided by 8, which equals 10. That is our minimum ratio. So we have to multiply these both by 10. So this would be 80, and this would be 720. And then so we add the two of them. So drug diluent total 800 milligrams, and then so then you find your strength, and so then that is 80 divided by 800, which is a nice 10%. So you take your how much you're trying to find, then divided by your strength. So that's 80 milligrams right there. So very, very nice, because now you're, for each one of these, our minimum weighable quantity has been our aliquot. So it's been super nice. All right, let's do it the way that the book did it now. Okay, so the book has that they weighed out their drug and they did 160, and then diluent is 34, oh no, 340. So then their total is 4,000 milligrams. And then so it's 160 divided by 4,000 milligrams. And so their strength is 0.04. And then that is 8 divided by 0.04. They have to weigh out 200 milligrams to get their same active ingredient. So they ended up using twice as much, almost 4 times as much as mine, and then they had to weigh much more. So you have quite a bit more waste because the strength was only 4%, whereas ours was 10%. So ours was like 2.5 times stronger. Okay. So a prescription has a sensitivity requirement of 6.5 milligrams. How you weigh 20 milligrams of a substance with an error not greater than 2%. So let's do it the way I would do it. So min quantity is 6.5 divided by 0.02 to find our minimum weighable quantity, which is 325 milligrams. And then we're looking for 20 milligrams of a substance. So do 325 minus 20 equals 305. And then we have to find our ratio, which is 325 divided by 20 equals 16.25. I don't like this 0.25, so we're going to go to the next one, which is 17. So times 17 is 340, and then times 17 for this one is 5185. That is a lot. So then our drug would be all right. So our drug would be 340. Our diluent would be 5185. And then our total would be 5525. Okay, and then we have to find our strength. And then that is 340 over 5525. And that is 0.06125. Okay. And so if you take 20, which is the amount that we're looking for, and divide it by 0.06125, blah, 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 you'll find that your minimum weighable quantity is 325 milligrams. Or not your minimum. That is our minimum weighable quantity, but that is the amount that we are going to take to find that has 20 milligrams of the active ingredient that we need. Okay. So we're going to go look at the book. The book did 400 milligrams. Then they did 7,600 milligrams. And then so they found 8,000. So then their strength was 400 divided by 8,000. And so that is 0.05. And then so 20 divided by 0.05 is equal to 400 milligrams, which is a difference of 75 milligrams. All right, so parts of aliquot by water. So this is going to be a little bit different. So we need our ratio. However, we don't necessarily have the same setup when it comes to the where is that? Where did I put that? Oh, right. Okay, found it. Okay. So with a graduated cylinder, its minimum quantity is always 2 milliliters. It is not 1. So that's going to kind of change it. However, we need to do the minimum weighable quantity of this. So of the scale. So the minimum quantity of the scale, all right, so it has a sensitivity of 4 milligrams, weighing error of 0.05, so that's 80 milligrams. And so we have to do, this is 15 milligrams. Just going to convert that really quickly. All right, and then so we're just finding the tartar one. So we take 80 minus 15, and then we find that is 65. But we don't need that right now. And then so we have to find the minimum ratio. So the ratio is 80 divided by 15, which is 5.3. Because we don't want that, we're going to make it a 6. So 15 times 6 is 90 milligrams. But we still need this ratio. So the minimum weighable quantity on the graduated cylinder is 2. So we need 2 milliliters times the ratio, which is 6. So we're going to have 12 milliliters total that this is going to be diluted. So we take 90 and we divide it by 12 milliliters, so milligrams, and then we find that that is 7.5 milligrams per milliliter. And so if we double that, we're going to find that it's 15 milligrams for every 2 milliliters, which is your minimum weighable quantity in your graduated cylinder. So we figured this out on both minimum quantities. So, and the book actually comes up with this as well. So we would measure out 2 milliliters of this stuff, and then so you would have 2 milliliters of the active ingredient stuff, and then you would add 118 milliliters of the syrup to get the 120 total, but that is without us adding the sodium citrate. So we have to add the sodium citrate as well. So I would actually add that. But yeah, our scale can weigh out that, so we don't have to worry about that. But that is the same way that you make it in the book. So the book has the same way. So this one is, we're going to do 0.6 milliliter of a coloring solution. And we're going to use a 10 milliliter graduated cylinder calibrated from 2 to 10 milliliters in 1 milliliter units. So we have our minimum weighable quantity, which is 2. So we take 2 milliliters, and then we take away 0.6 milliliters. And then we find that that is 1.4 milliliters. And so we have to find our minimum ratio, which our minimum ratio is going to be 2. So this is ratio is going to be 2 divided by 0.6, which is 3.33. And so we would normally round that up to 4, but if you multiply 0.4 or 0.6 by 4, you don't come out with a nice even number. So you have to come up with something that's in the middle, and that is 5. So it has to be above that number. So if you multiply the 2 of them by 5, you end up with, so times 5, and then multiply that by 5. And so you find that 0.6 times 5 is 3, and then 1.4 times 5 is 7. this is 3, this is 7. And so you have your drug, which is 3, diluent is 7, your total is 10. And then so you find that 3 divided by 10, find your strength, is 0.3 milliliter per milliliter. And so you're wanting to find a total of 0.6. So you multiply that by 2. So that. So 0.6 divided by 0.3 equals 2. So you need 2 milliliters again. Okay. Using a 10 milliliter graduated cylinder, find 1.25 milliliters of a dye by the Aliquot method. Use water as diluent. So our minimum weighable quantity is 2. So 2 milliliters minus 1.25 milliliter, and then that equals 0.75 milliliter. And then we have to find the ratio. The ratio is 2 divided by 1.25 is equal to 1.6, which is that's our minimum ratio. However, just looking at this, we could probably just do this times 4. So this becomes 5, and this becomes 3. And then you have your drug is 5, your diluent is 3, that is 8. 5 divided by 8 to find your strength, and that is 0.625 milliliter per milliliter. And then so if you multiply that by 2, or you take 1.25 divided by 0.625, find that you have to weigh out 2 milliliters, which is, I believe, the same in the book. Yes, so it's the same in the book. So then, for the next one, okay, so we're doing the same kind of thing. So we do 2 milliliter minus 0.75, that equals 0.125 milliliter, and then our our minimum ratio is, what is our minimum ratio? I don't have it written down. Right, 2.6. So 2.6, repeating. And then so, because we did 4 and it was kind of the same thing, so we're going to do 4 again. But just double check your minimum ratios because sometimes you can get it screwed up. So that's 3, that's 5. So then our drug is 3, our diluent is 5, our total is 8. So then 3 divided by 8 is equal to something. Let me look this up. 3 divided by 8, 3.75. And then you do 0.75 by 0.375, and that equals 2 milliliters, which is identical to the book. So that is how you do those. That is it for chapter 3. So